In the last class, we did buffers. So, Ashita, you were there in the last class. So, what's a buffer, Ashita? Yeah, what's a buffer? A buffer resists any change in pH. And what is the condition needed for a solution to be buffer? Condition needed for a solution to be buffer. So, from here, we started the buffer. Before that, we did the nature of oxides. So what is a buffer solution? Which resists any change in pH. And the condition for a buffer is that, yes, Ashita, that there should be a weak acid or weak base with its conjugate, the common ion effect. We discussed common ion effect also in the last class. So a weak acid with weak base with its common ion, with its conjugate base or acid is going to work like a buffer. And we did the mechanism of the buffer action. We discussed many questions based on that, how to identify a buffer, all these things we did in the last class. And then we started doing this part, and it was easy to identify here that is not a buffer. So those who were not present, okay, no problem. Can you change your name, please? Those who were not present in the class, they can watch the video. This is not a buffer. This one is not a buffer. And then we discussed this example and we said, yes, it's a buffer. And this one is not a buffer. So this question we were doing in the last class in the end. And I said, I'm going to give you more examples of this type. For example, let's say there is ammonia. Ammonia is a base. Is it a weak base or strong base? Ammonia is a weak base? Yes, it's a weak base. And with this ammonia, I have taken hydrochloric acid, which is a strong acid. If I ask you to identify this solution as a buffer, then you have to understand that you are dealing with a weak base and a strong acid, so there is a reaction. Now let's see the reaction. Acids and base, they react. Acids, they don't react. Base, they don't react. But if there is an acid, especially a weak acid with strong base, then there are chances that the solution can work like a buffer. Let's see how. Make this reaction happen. So ammonia react with HCl and it forms ammonium and chloride. Ammonium chloride. Yes, Dhruv, very good. Now, how to identify whether this solution is going to be buffer or not a buffer? We need to see the amount of ammonia and hydrochloric acid given to us. Let's say the amount of ammonia given to you is 0.2 molar. Hydrochloric acid given to you is 0.3 molar. This is initial amount. This is the reaction. Initially, before the reaction, ammonium is 0. Cl minus is 0. Now finally, out of these two, which one is the limiting reactant? And Dhruv is already writing, because this reaction is 1:1. 1 mole of ammonia reacting with 1 mole of HCl. 0.2 will react with 0.2. So ammonia is the limiting. Yes, Sanjana. And HCl, how much HCl is left? 0.1. How much ammonium is formed? How much ammonium is formed? 0.2. Cl minus. Isabella, start answering questions. 0.2. Okay, good. Okay, then finally, look at the final solution. Do you have the weak base there in the final solution? Final means, look at this picture, this one. Do you have weak base? No. What is there in this final picture? A strong acid, HCl, and is Cl minus is spectator here, children. You remember Cl minus is a very weak conjugate base. It's just a spectator, so just ignore it. What else is there? Ammonium. Ammonium is the strong conjugate acid of ammonia, but this is acid. This is also acid, isn't it? Acid. This is also acid. This is also acid. Cl minus, just a spectator, ignore it. It is the conjugate base of HCl. It's a spectator ion, not doing anything in water. Lying there, it cannot do anything. It's just a counter ion over there. Counter ion means helping in neutralizing the solution. Nothing else, no other role, right? So Cl minus, I need not to think about it. So what is there in the solution? You have a strong acid and a weak acid. Is it a buffer, children? A strong acid with a weak acid. Acid with acid. Is it a buffer? Lasya, is it a buffer? No. Vinaya, did you watch the video? I uploaded the video in my night around 11, just because I want all of you to watch it and come prepared. Okay, so you're understanding. If you have questions, you can ask questions. Okay, now this is your not a buffer, not a buffer. Isabella, you keep asking question in case you have any problem. Shrihan, you also. Those who were not there and could not watch the video, they can ask. I can help in simple questions, not the complete topic. Okay, now I'm changing the situation here, children. Check the situation here now. Now this time, this is 1.0. This is 0.7. Initially, no reaction. Now, who is the limiting reactant? Change this final situation. Which one is the limiting reactant now? This is 1.0. This is 0.7. It will be the same time. Okay, children, I know that you have some time change happening tonight. Lasya, can you put this question directly in the chat to everyone? I will answer your questions only if it's visible to all of you. Okay, Lasya? Yeah, thank you very much. Lasya is asking this question. So the answer is it will be at the same time. Means 7 a.m. for PST and 10 a.m. for EST. No change in the timings. Okay, your timings will be same. That I will change my time. Okay, so please join the class at the same time. Okay, so back to the question, which one is the limiting reactant? Vinaya is saying HCl is the limiting reactant. So this will become 0, HCl. And ammonia will be, how much ammonia is left? Can you fill this? How much ammonia is left? How much ammonium is formed? How much Cl minus is formed? 0.3 ammonium, 0.3 Cl minus, 0.3. I'm going to ignore Cl minus. Who is going to tell me why? Ignore Cl minus. Why? Because Cl minus is a conjugate base of a very strong acid. Strong acid, very strong, right? It's the conjugate base of a strong acid. It is weakest there. It is weaker than water. This Cl minus is weaker than water, and the weak things are stable and they are not going to interfere in anything. So they are there as spectator ions. Okay, so now who all is there in the solution? Now this is B question we are doing. Who all is there in the solution? Oh, yes. Shri, I picked up your answer. How much ammonium? Yes. Who is this? Vinaya. Very good. 0.7, 0.7. 0.3 is left. HCl is the limiting reactant. So HCl is going to determine how much ammonium and Cl minus is going to form. Good, Vinaya. Very good. Thank you very much. So finally, what all is there in the solution? You can see ammonium and you can see ammonia. Now, ammonia is a weak base and ammonium is its conjugate. It's conjugate. Conjugate of the conjugate acid of the weak base. So, is it a buffer? Yes, it's a buffer. These kind of questions will be there. It's a buffer. One last question based on this. Try to answer it. If the initial amount of ammonia is 1.0 and hydrochloric acid is 0.5, ammonium initially 0, 0. Before the reaction, initial means before reaction has started. So how much ammonia is there left? 0.5. How much HCl left? How much ammonium formed? How much Cl minus formed? Isabella, your name is not appearing here. Why 0? Nasya, Shrihan, Isabella. This is final situation, final. It's 0.5 Cl minus. Okay. Now look at the final situation. Who all is there? Who all is there? Ammonia and ammonium. And their amounts are equal. See, 0.5 molar of this and 0.5 molar of this. Their amounts are equal. It is the best buffer. Best. So what's a best buffer? A best buffer is when the concentration of the weak base is equal to the concentration of its conjugate acid. Concentration of a weak acid is equal to the concentration of the conjugate base. This I discussed in the last class also, because in this case you have plenty of the ammonia and plenty of ammonium. And if you remember the buffer action, ammonia and ammonium, excess of these are the one which are controlling the pH. It's the best buffer. Remember that, best buffer. So what's the condition for the best buffer? That the concentrations of the base and the common ion, this conjugate is common ion, ammonium. Ammonium and ammonia, when their concentrations are same, it will work like a best buffer. So watch the video of the last class to understand why is it a best buffer. Okay, now I'm changing the question and you people are going to help me. This time we are working with HF. And I have given you 20 ml of 0.1 molar HF. This time volume is given, molarity is given. You are adding this into 10 ml of 0.1 molar NaOH. You are adding. So when you are adding, what is happening to the volume? volumes are changing. If you remember, I told you that you write down somewhere when you change the volumes, when you add two volumes, then molarities changes because molarity by definition is moles over volume in liters or millimoles over volume in milliliter. You change the volume 20 plus 10. When you add them, then this is no longer zero point 0.1 molar. Molarity will change. So generally, whenever volumes added, then you start working in millimoles or moles. Don't work with molarity because that molarity is changing. This I discussed with you when we were doing pH of some acids and bases. At that time, we were mixing two acids and I discussed in detail. In unit 4 also, we did this concept. So here I'm adding volumes, so I cannot work with molarities. So first I'll write down the reaction HF, which is a weak acid, NaOH, which is a strong base. We know it. It will give you, can you complete the equation? Acid base reaction, acid base. What is formed? Mhm. Acid and base. What is formed? HF will give H plus and F minus. NaOH will give Na plus and OH minus. Do plus minus? Yes, Vinaya, very good. H2O plus NaF. Yes, Isabella, good. Acid base reaction, you are getting the salt and water. Now, initially, now I'm going to work with millimoles because this is milliliter. So, how to calculate millimoles by using this equation? Can I say millimoles are equal to molarity times volume in milliliter. Shrihan, you're understanding all these things because this is something from unit 4. So keep answering, okay? So can you multiply this 20 with 0.1? So how many millimoles of we are working with millimoles, children? We are working with millimoles. So how many millimoles of HF? 2. How many millimoles of NaOH? NaOH? NaOH. Why 4? Yeah, good. 1. And water initially 0, 0 before the reaction, right? And finally, sorry, not the change. We are not writing equilibrium. We are writing a reaction here. Finally, how much HF? Who is the limiting reactant? How much HF? 1. How much NaOH? Yeah, this is the limiting reactant. Water? 1. Otherwise, we are not interested in water. NaF? 1. So finally, in the solution, what all is there? In the final solution, what all is there? Look at the final picture. Do you have HF in the final picture? Yes, see, excess 1. Do you have NaF? Yes, here. Water, we are not interested. Water is there in abundance. Reaction is done in water. 0.1 molar means plenty of water. Molarity, moles per liter of solution. Solution is made in water. So there is plenty of water. It's a solvent. So HF and NaF is there in the final picture. What is HF? A weak acid. What is NaF? It's salt. I can call it as it's salt. Is salt means you can see this F minus here, the common ion. This is F minus, this is F minus. So it's a weak acid with its conjugate or with its salt. You can see this language if you're reading the book. Weak acid with its salt, weak acid with its conjugate. Is it a buffer? Yes, it's a buffer. So, and what's the molarity of HF? Can you work out the molarity of HF? Molarity is millimoles over, this question I'm adding from my side, volume in milliliter. We have decided it's a buffer, but if I say what's the molarity of HF? So molarity of HF is how many millimoles? 1. And what's the total volume? Certain combinations. I told you the condition, weak acid with this conjugate or weak base with this, only 2 combination. There are not many combinations, Dhruv, only 2. I'm answering question asked by Dhruv. There are only 2 combinations, weak acid with its conjugate or with its salt, weak base with its salt. These are the only 2. If you can see them finally in the solution, then yes, it's a buffer. If you cannot see them, if it is not there, then it's not a buffer. And what is a buffer? Which resists change in pH. So watch the video of the last class to understand that buffer action, how it is controlling the pH. And remember, there are only 2 conditions, only 2 combinations are needed, only 2. Is it okay, Dhruv? So what are the 2 combinations, children, which we have to keep it in mind? Weak acid with its salt, first. Second, weak base with its salt. If in the final picture you can see there is a weak acid with this conjugate, there is a weak base with this conjugate, then it's a buffer. Otherwise, no. Okay. So we are working with the concentration of HF in the final picture. So you can see that there is 1 which is left. So it is 1. And I think somebody was giving me the total volume, Vinaya. Yes, good. What's the total volume? 20 plus 10. Don't take 20 only. So 1 divided by 30. That's the molarity of HF. Can you work out the molarity of NaF? All of you, please work out the molarity of NaF. We are working with millimoles. This table is in millimoles. And you have the total volume here in milliliter. So NaF, 1, this is what is left, 1. 1 over 30 again. Yes, Dhruv, very good. Yes, Isabella, perfect. Yes, Sanjana. Okay, good. So things are becoming slightly not complicated, more mathematically. We have to involve now. Mathematics is dominating now. So I want all of you to keep answering. Otherwise, you will not understand what I'm doing. Mathematics, you can answer. And don't worry about your wrongs and right. If you're wrong, I'll correct you. And if I'm correcting you, don't mind it. Don't take it seriously. We are learning. All of you are students. You are correcting me, and I'm saying thank you. So when I'm doing error, like we did error earlier, and Vinaya, she corrected us. So we can correct each other. Okay, we are learning together. Okay, ready for the next concept? The next concept is how to calculate the pH of a buffer. So first, let's see this solution, this one. So first, let's see, is it a buffer? So I'm going to give you 2 methods. Finally, we'll be doing only by 1 method, but this is also important to know how to calculate the pH by using rice table. We'll use a rice table. So first, is it a buffer? This is the acid or base? What is it? It's an, oh, Dhruv. It's an acid, right? Dhruv, it's an acid. You have hydrogen. Out of these two hydrogen, this hydrogen is acidic, which is on the oxygen. For the base, there should be metal here. Is it a metal? It's a non-metal, right? No, this hydrogen is not acidic, Dhruv. This hydrogen is on the carbon. This is acidic. But yes, you can write it like this: HCHO2. You can write like this. This is starting with this hydrogen, which is actually on the oxygen. So it's an acid. And what is it? It is its conjugate. As I said, here this hydrogen is acidic, which is on the oxygen. It's an oxygen containing acid. This. So you remove this hydrogen, you get its conjugate base. So this is the conjugate base, isn't it? This one. So there is a weak acid with this conjugate. So is it a buffer, Nasya? Is it a buffer? Oh, Dhruv. This is CO minus K plus. It's a salt. K. What's the charge on K? Plus 1. So what's the charge on this conjugate base? Minus. I'm interested in this. For a buffer, I have to see that, do I have a weak acid? You said yes, you have a weak acid. This is weak. Do I have its conjugate? Yes. See, this is the conjugate of this acid. You're understanding this, children? How can I identify this one is a buffer? So I'll work with this. I'll say, okay, this is the weak acid. Now you work out the conjugate. I told you already that this hydrogen is acidic. So remove that. Now check. Is this present here? Yes, it is. Minus plus. This is the salt. You can call it as its salt. It's of this weak acid. Salt. It is the salt of this weak acid. Isabella, you're understanding? And this one has this conjugate base. See? And K plus, why I'm ignoring K plus? Anyone? Because it's a conjugate of a strong base, KOH. Spectator. Yes, spectator. Ignore it. So that's why I was ignoring it when Dhruv said that why you're not taking K. K is totally soluble, strong electrolyte, is a spectator, is a very, very weak in nature, is not going to do anything, lying there as a counter ion. Counter means is going to neutralize the solution. That's it. Okay. Now, so we have decided this is a buffer. It's a buffer. Calculate the pH. So we start with this acid, HCOOH. You set up the equilibrium. It's a weak acid. It's undergoing partial dissociation, giving you, yes, complete the equation. Isabella, dissociate this acid. You already know its conjugate here. So it's going to dissociate as HCOO minus plus H plus. Is it okay? Everybody has understood this? Dissociation of the weak acid. We have done it so many times. Now this is the reaction. It's a weak acid. I will use Rice table. Reaction, initial, change, equilibrium. I will use Rice table to determine the pH. So how much is this initially? 0.30. Rice table is always in terms of molarity. It is never in terms of the moles. So never write rice table in moles or grams. It's always in molarity. And we are dealing with molarity here. And how much HCO minus initially? Do we have HCO minus initially? Siri. Yeah, this one. See, this one. 0.52. It's not zero, right? Vinaya, it's 0.52. Isabella, Sarayu, you're there? Ashita, Sanjana, see the rice table is taking a shape. There's a change here. Your formate ions are not zero. Sarayu, you're understanding everything, Sarayu? You didn't join the class. Did you watch the video? How's your health? You're doing good, Sarayu? Okay, great. Keep asking questions, okay? Children, I don't mind if you ask any question. Only thing that I cannot teach you the complete topic, but simple questions I can answer without wasting much time. So H plus here is 0. This is 0. Formates are 0.52. See, this is a different rice table. Now assume the change. Minus X, plus X, plus X. If X amount has dissociated, right? And the equilibrium 0.30 minus X. Then this one, how much is this? Here, what should I plug in? Yeah, complete it. 0 point, yes, very good, throw, plus X. So this is the equilibrium. What is Ka? The acid dissociation constant. It is the concentration of HCO minus times concentration of H plus over concentration of HCO minus H is the normal equilibrium constant, concentration of the product divided by concentration of the reactant. Now you plug in all these things here. Is 0.52 plus X times X divided by 0.30 minus X. I don't remember exactly what's the Ka value. So what I can recall, I think is 3.4 times 10 raised to power minus 4, something like that. Okay. That value will be given to you. So don't worry. You need not to memorize. 1 second. I can check and I can give you the value. Oh, 1.8, not 3.4. 1.8. This value is 1.8. Now, Shirihan has already helped us in solving equations. So either you do approximation is valid here, children, or you use your graphing calculator and calculate the value of X. So who is going to help me with the value of X? If I use approximation, I'm not using graphing calculator. If I'm using approximation, which I think is valid here, then 0.52 plus X will become 0.52. Because in approximation, we are thinking X is very small. 0.30 minus X will become 0.30. So approximation, when I do approximation, check here. This minus X can be ignored and this value I'm going to take it as 0.30. 0.52 plus X can be taken as 0.52. Get the value of X. Yes. Okay. No, I think X should be this. I think Dhruv has given the right answer. He's taking two significant figures, so that's why he's taking as a 1.0. But take it completely. And remember one more thing. They are asking pH. So take care of significant figures only in the last answer. Dhruv, Shriyan is asking a question. Can you answer that? Otherwise, use your normal scientific calculator and get the value of x. So in the exam, you can use approximation. You will be slightly away from the answer and it's not going to harm you much. So, Ashita, what's the answer for x? You calculated? Yeah, I'm still getting the same answer. After doing this, I'm still getting the same answer. I'm doing the approximation and the same answer. It means approximation is valid. You can calculate the degree of dissociation. You remember the formula of degree of dissociation, children? Degree of dissociation of acid we did earlier. It is X, the amount dissociated, over the initial amount of the acid, initial, multiplied by 100%. How much is X? X is 1.038 times 10 raised to power minus 4. And how much was the initial concentration? 0.3430 multiplied by 100%. Solve it. How much is this percent dissociation? It is 0.0346. Okay. Dhruv is asking something from you, Shrihan. Now check why I'm calculating this degree of dissociation. So this degree of dissociation will confirm whether my approximation is valid or not. Can you see the degree of dissociation is less than 5%? If it is less than 5%, less than or equal to 5%, then is valid. Valid approximation. Many teachers, they are very serious about it. So maybe your teacher is also talking about it in the exam. So you can check whether my approximation is valid. So my approximation is valid. Now this is X. X is, now let's come back here. What is X? X is H plus ions concentration from the rice table. So can you work out the pH now? Yes, pH. pH is negative log of concentration of H plus. So it is negative log of 1.038 times 10 raised to the minus 4, and the answer is this. Now this answer has two significant figures, you can see. So don't do sig fig here. Do the sig fig in the final answer. Okay. By the time Shrihan and Dhruv are thinking about what's the error in the calculator, we finish with this question. We calculated the pH of this buffer. So maybe Dhruv, you can discuss with him after the class. Is it okay, Shrihan? Yeah, because I'm teaching you now new thing. Okay, so what we are doing on this slide, we are calculating the pH of a buffer, and we are using the rice table, the old method. The weak acid is rice table. We are plugging in the values, and here the approximation is valid. So I did the approximation. I didn't use the graphing calculator because I'm not getting any quadratic equation. So I simply used my normal scientific calculator, calculated the value of X and then pH, the way we were doing earlier. But because as I said, approximation is valid because it's a buffer. In the buffer, there is hardly any dissociation. If you remember, in the buffer, we have excess of this, excess, and we have excess of this. This is nearly zero, nearly zero. So it means there is hardly any dissociation. That's the reason you are getting such low dissociation constant, right? So due to this common ion, because you have added this potassium formate, there is excess of this and excess of this. So approximation is valid. Taking advantage of this, that approximation is valid in buffers, we are going to get an equation which is called as Henderson Hasselbach equation. This we have done. This equation. We are going to make an equation based on this concept that approximation is valid. Henderson Hasselbach equation. And you will use this equation to calculate the pH. Okay, let's take a weak acid, HA. So HA is going to dissociate as H plus and A minus, we all know. Now in this solution, we are adding any sodium with A minus, sodium, the salt of this weak acid. So it's a buffer. This salt is strong electrolyte, is 100% dissociated, strong. See, I have made only one single arrow, Na plus and A minus. So in the solution, you have plenty of A minus access, right? Plenty and plenty, plenty of A minus. And because of this common ion, A minus is common in both the equations. Now they are present together. So equilibrium is going to shift in the direction of HA, Le Chatelier principle. It will shift in this direction. So you have plenty of this and you have plenty of this. And that's how it's going to work like a buffer. So this is the situation. Now I want to calculate the pH. So I'm going to use this particular reaction, the weak acid, because it is the one which is giving me H plus. I want to know the pH. So what should I do? I'll write down the equilibrium constant for this acid, Ka, which is concentration of H plus times concentration of A minus over Ha. Sarai, we are okay with this Ka expression? You can take it as review also because all these things we did earlier. Now children, what do you want to calculate? pH? Isolate this H plus. Isolate. When I isolate this H plus, my equation becomes, I'm taking it on one side. The equation has become Ka times concentration of Ha. Yes, through, very good. Divided by concentration of A minus. This is the equation now. Now do one thing. Take negative log of this equation. Negative log of the complete equation. So Isabella, what is this? Negative log of H plus is called as? Negative log of H plus is pH. And negative log of Ka is pKa. This is multiplication. So it will become plus. And then you have negative log of concentration of Ha over concentration of A minus. Generally, scientists, when they try to make an equation, they try to avoid these negatives. This is standard thinking. So if I want to avoid this minus, I can reverse the ratio. Check here what I'm doing. pH is pKa plus, now I'm reversing the ratio. I'm taking A minus in the numerator and Ha in the denominator, and this negative log will become positive log. And children, this is your Henderson equation. This is Henderson Hasselbach equation. Henderson and Hasselbach, they are the scientists who gave us this equation. Buffers are very important. In biolabs also, buffers are very important. If you want to become a biologist, buffers are more important than if you want to become a doctor, a research scientist. So every time when we are working in the biotech labs where we are discovering new medicines, we need a buffer solution. We cannot take a solution which can jump by adding H plus. We cannot adjust very strong changes in the pH when we are working in the lab. So generally all these work in biolabs are done in buffer solution because blood, what is blood, children? Yes, students who were there in the last class. What is blood? Blood is a buffer. Our biological system is a buffer. When you eat some acid, like you're not eating strong acids, you're eating these weak acids. All fruits, all vegetables, your cereals, your oils, fatty oils, they are fatty acids. Whatever oil we are using for cooking, they all are fatty acids. They are acids, but they are weak. It's not our stomach has very strong acid, hydrochloric acid. So our biological system has plenty and plenty of acid. But can you see the pH of the blood? Slightly alkaline. This is the pH of our blood, human blood. And if this pH changes, you will be in hospital. pH is so important. If pH changes, then we are not well, then we are sick, right? Okay, so that is the reason buffers are very important. So then you can use straight away this equation, the Henderson equation, which we have derived. Derivation is not the part of your learning. I have just shown you the derivation to make you comfortable with the equation. So what's the equation? pH equals to pKa plus log. What is A minus? Can I say conjugate base? A minus is the conjugate base, right? A minus conjugate base over weak acid. This is your Henderson Hasselbalch equation. So don't make any rice table the way we did earlier. Now we are not going to do that. We are going to use our Henderson Hasselbalch equation to calculate the pH of a buffer solution. Ready for a question? So please practice this Henderson Hasselbalch equation. It will be given to you in the exam also, in the formula sheet, in new equation, right? This is with acid buffer, acid. But if I'm dealing with basic buffer, weak base with a salt, basic buffer. This one is acidic buffer. Children, if you are writing notes when I'm teaching you, I request you to leave gaps. Like I have written the equation. Now on the top, I'm writing acidic. So you need a gap. So generally, when I'm teaching, after writing the equation, I'm writing so many things around it because I'm in the part of explaining. I cannot explain in one go. I have to come again and again on the same thing. So then you need space to write again. I'm getting the space because I can erase and I can write. But once you have written, you will not get space to write over there. So when you are making notes, leave gaps, good amount of gap, at least 2 lines, 1 line or 2 lines, so that you can write if I'm writing again something. So what is a basic buffer, children? Basic. In the basic buffer, there is no pH. Then it is pOH. There is no pKa. Then it is pKb log. In the numerator is conjugate acid, the acid of the base. Denominator is, so you can use this equation, but you can use this also. I'll show you some examples. So in the exam, you will be given only one equation, this one. And I can use the pH equation also because you already know that how to convert all these things. pOH means 14 minus pH. pKb means 14 minus pKa plus log this. When you rearrange, you will get the same equation. So this equation we are going to practice now. Ready for questions? Henderson Hasselbach equation. So never use rice table because it's very time consuming. So when you are working with buffer, you can use Henderson Hasselbach equation is written here. See? You can practice, you can memorize. Another, okay, that I'll teach you with the question. There is one more important point with this equation. We'll learn it while doing the questions. So is it a buffer? First you identify, is this a buffer? I need Ka. Ka will be given to you. Ka has no units, you know that, because it's an equilibrium constant. Equilibrium constant, Kc, Kp, Ka, Kb, Ksp, all these things we have done. They have no units because they are the ratio of the concentrations or the pressures. So what is pH? pH is negative. Oh, sorry. I'm defining the pH. No, I'm going to use the Henderson equation here. It's a buffer, right? It's a buffer. Weak acid with this conjugate. It's a buffer. So pH equals to pKa plus log concentration of the conjugate base over concentration of the acid. Numerator has the conjugate base and denominator has the acid. So pH equals to, plug in the values. pKa means negative log of 1.8 times 10 raised to power minus 4 plus log. What is the conjugate base concentration? Yeah, Ashita, you were not there in the class. It's okay. We started with the Henderson equation. You heard about Henderson equation when you were kicked out of the class at that time? We were doing Henderson equation. pH equals to pKa. This one is already written here. Now we are going to use Henderson equation to calculate the pH. Ready, children? So conjugate base. What's the concentration of conjugate base here? Concentration of conjugate base. Srayu. This one. This is the base, right? The salt. This is the conjugate base. This part, CO minus. So 0.52. What's the concentration of the weak acid? The acid. Yes, very good. Get the pH. Get the pH, children. And then we are going to do few more questions here. Okay, this value is it 3.74, this one? Right? Right. Okay, and then this answer is positive or negative? This answer is positive because this number is greater than 1. Log of any number which is greater than 1 is always going to be positive, right? Positive. And when you take the log of this value, so understand this thing which I'm just right now talking about. If you take logarithm of any number which is greater than 1, answer is positive. It's very important concept. So I'm getting 0.2388. I will do this sig fig later on. How much we are getting when you add? Everybody is answering 3.98. Sarayu, you are doing calculations. You have calculator with you. 3.98. Now I'm going to do sig fig here in the last. Okay, good. Is this pH greater than pKa or less than pKa? This pH. pK is this. So pH is greater than pK. pH of the buffer will always be greater than pKa if the concentration of the conjugate base, this base, is more than the concentration of the acid. Am I right? This is a condition. This is a question. They can ask this question from you. If you have made a buffer where the concentration of the conjugate is greater than concentration of the acid, then log of this number will be greater than 1. Log of the number will be a positive number. That positive number will be added in pH. And pH will become greater than pKa. So it means the buffer will be slightly more basic. pH high means basic. And that's quite understandable. This is conjugate base, right? If conjugate base is more, then pH is greater than pKa. It's easy to memorize also. Okay, now let's see. This is situation 1. Now I'm giving you situation 2. All of you, please answer here. Sarayu, I'm waiting for your answer. If let's say the concentration of the formic acid is 0.30 molar and its conjugate base, this one, is also 0.30 molar. Can you calculate the pH now? Calculate the pH. Use this Henderson equation. Isn't it pKa plus log 0.30 divided by 0.30? And what's the value of log 1? Log 1 is 0. Yes, so it is pKa plus 0. So don't you think that in this situation pH equals to pKa? Which is here as 3.74, right? In this example, right? So what we have to take away from here is a very important concept. Please mark it. If you remember, I was telling you the best buffer. When can I get a best buffer? When the conjugates are conjugate and the weak acid or base, whatever. Like here is a weak base acid and is conjugate. When their concentrations are equal, then it's the best buffer. So what is the other condition now I can add for the best buffer? Whenever pH equals to pKa, then it's a best buffer. Yes, Sanjana. Sanjana is writing a very good line, children. The best buffer is when weak acid or weak base have the same amount as its conjugate, when they are equal. You know, these are the one which are controlling the pH. This is acid is controlling if you add some base. This is base is controlling when you add some acid. If they are in equal amount, it means it's equally effective in controlling acid and base. And we call it as best buffer. Very balanced buffer, best buffer. Best buffer, pH equals to pKa. Best buffer, the concentration of the weak acid is equal to its conjugate. And then we are going to understand this best buffer on a graph also. It's a very good question. Best buffer. Please memorize it. Right here, best buffer. Very important question, right? Now I'm going to discuss third situation. This third situation, all of you are going to help me. The third situation is that the formic acid, this acid has a name, formic acid. So don't worry. I have this habit of calling chemicals by their name. I know the names, that's why I'm calling. You don't know, so leave it. This is formic acid. Formic acid has the concentration of 0.30 molar, 30 molar, and the formate, the conjugate base, formate, 8 means oxygen has the negative charge. You know, polyatomic ions, sulfate, nitrate, carbonate. This is formate. This ion is there in the polyatomic ion list given by me. It is, let's say, 0.20 molar. Can you calculate the pH here? Get the pH. Use Henderson equation. We are not making any rice table. Use Henderson equation. pH equals to pKa plus concentration. Can you give me the ratio, children? What should come in the numerator? What should go in the denominator? Sarayu, what should be in the numerator? Lasya, Saranya, start answering. Mm-hmm. Dhruv, see, I'm calling the names, so it doesn't mean that you cannot answer. Anyone can answer. Isabella, what should I plug in here in the numerator? Look at this equation. Identify your conjugate acid and here, look at this equation. Yes, it is 0.20 divided by 0.30. Now this number is greater than 1 or less than 1? This number is less than 1. And logarithm of any number which is less than 1 is a negative answer. You can check it. This answer will be negative. pKa we already know, 3.74, and this number is now going to be negative because this is less than 1. How much is this? Negative 0.176. 0. Now it has become negative 0.176. So what's the pH? pH will be less than pKa. Yes. 3.56 for two significant figures, 3.56. So pH is less than pKa. Sarayu, are you there? Because I'm calling your name, but you are not responding at all. Are you there? Sarayu. You're not answering, dear. Are you struggling with understanding? And Saranya, you're not also answering. Saranya, you were answering in the last class very nicely. Start answering, okay? Simple question. Mathematically, you have to get involved with me. You should pick up your calculator, at least do the mathematics. It will help you in understanding what I'm teaching. It will give you a grip with the session. If you don't do mathematics, you will start wandering, your mind will be wandering here and there. So let's say you're not understanding the concept, but do the mathematics. At least this will force you to listen what I'm saying. Okay. Ready for another question, children? Something like that? Okay, this we have done. So we have not made the rice table. We are using Henderson equation, and you can see that we are getting nearly same pH what we were getting earlier. Earlier, I think it was 3.98, but now we are getting 4.01. So it's nearly same. Ready for this question? This one. What is this? Acid base. Mm-hmm. HNO2. What is it? HNO2. There is no metal here. There is hydrogen in the starting. What is it? It's an acid. Yes, very good, Sarayu. It's an acid. What others are thinking? It's an acid. What acid is this? Weak or strong, Isabella? It's HNO2. You already know your strong acids. I gave you the list of strong acids, children. You already know your strong acids. And if you check the name of this acid, it's nitrous. And all acids ending with us are weak. It's weak acid. One condition fulfilled. One condition. And what is this? Isn't it salt of this acid? Yes or no? If Ka again I said it will be given to you. So I'm giving you Ka of this acid. It is 1.0 times 10 raised to power minus 2. So don't worry, I've taken some value, approximated value, because we cannot memorize. So in the question paper, Ka will be given to you. During review classes, we'll be doing the real AP questions, free response as well as MCQs from every unit. And we'll combine the units also. So review classes will be very, very important. So this is Ka. So is it a buffer? Is this solution a buffer? Do you have a weak acid with this salt? Yes. Once you decided it's a buffer, use Henderson. So Henderson equation is pH equals to pKa plus log. What should come in the numerator? What should go in the denominator? Mhm. Numerator is NO2 minus. No, no, no. The conjugate base, Dhruv, NO2 minus. Sorry, I marked it, but I was actually telling you the conjugate base. This one, this one, this one. Yeah, my pointer was on the wrong thing. But I was just saying conjugate base, this one, right? And the denominator is acid. So this you have to memorize. Numerator, the base, conjugate base, or the salt. You can call it salt also. Denominator is the acid. Now calculate. What is pKa? Negative log of 1.0. You don't need calculator to calculate this pKa. plus log, plug in the values. Yes, Sarayu, what should be the ratio here? How much NO2 minus? How much HNO2? What is log 1? Log 1 is 0. pH equals to pKa, which is 2 point, going for 3 significant figures. Is it a best buffer? Yes, best buffer. Because the concentration of the conjugate and the acid are same. It's the best buffer. Ready for next question? For the next question also, you have to see that whether it's a buffer or not a buffer. First thing is always check, is it a buffer or not a buffer? I'm going to erase this. In the first case, pH equals to pKa, right? Best buffer because the concentrations are same. Log 1 is 0. Here is HF. Let's say the Ka value of HF is 1.0 times 10 raised to power minus 3. So again, I'm giving you value from my side. So HF is a strong acid, weak acid. HF, strong, weak. Can you name 3 non-oxo acid which are strong? 3 non-oxo acid. I asked in the starting also. 3 non-oxo acids. There are only 3 non-oxo strong acids. HBr, HCl. Very good, Dhruv. So I'm repeating a lot, children. It should help you in memorizing. But somehow I've seen that many of you don't answer. So that's quite hurting. You must try to answer, okay? Because my aim is to make you learn in the class. And you can learn if you participate. If you're not participating, then I cannot do anything. So HF is a weak acid. What is KF? KF is it salt, right? It's salt. Because if HF is an acid, what is its conjugate base? F minus. You know how to check it. And that F minus is here. So I have a weak acid with its conjugate. Is it a buffer? So every time in the exam, because exam is not going to give you questions only from buffers. Exam will have plenty of questions from plenty of units. So when a question is there, don't jump on using Henderson equation. First you check, is it a buffer? And then if it is yes, then you can come for your Henderson equation. pH equals to pKa plus log. Who is going to tell me what should be in the numerator? What should be in the denominator? Yes, Vinaya, what is there in the numerator? The conjugate base or the acid? We have two things, HF and F minus. So what is there in the numerator? F minus, yes, Ashita. And what is there in the denominator? HF. Yes, Vinaya. Now plug in the values. pKa is, take this Ka, this one. It's written here, Ka. Negative log of this value. If you take the negative log of this without calculator, you can say 3.00 plus log. What's the concentration of F minus? Yeah, give me the values. Look at the question and give me the value. How much is F minus? F minus is in this KF. KF, K plus F minus. So how much? How much is the F minus, children? F minus is 1. Yes, Vinaya, very good. And how much is your HF? HF is 0.60. You are reading question with me, children, then why you are not answering? If you are reading with me, why you are not answering? Yes, good. Is this value greater than 1 or less than 1? So it means pH, this answer will be positive, right? And pH will be greater than pKa. It has more of this conjugate base, more. So it is more basic, more basic. So sometime without calculation also you can answer. Like when I'm looking at this, even without calculation, I could have said that. I can see that the conjugate base is more. Base is more, means more basic. If acid is more, then more acidic. More acidic means pH is less than pKa. Base is more means pH is more than pKa. So even without calculation, if it is a multiple choice question, you can answer it. Is it okay? Okay, I'm going to erase this. So that's about your buffers. I'm giving you one question. You are not going to do any calculation, okay? There are three conditions. I'm making a buffer of HCN and NaCN, and I'm calling it as a buffer. Can you justify it's a buffer? Can you tell me why I'm saying it's a buffer? It's a buffer solution. Tell me why it is a buffer. What is the reason that this solution can be called as a buffer? So identify HCN. Yes, Dhruv. Dhruv is giving me the complete answer, Shrihan. HCN is a weak acid and NaCN minus CN minus C with is salt or is conjugate. You can call it as salt or conjugate. Yes, Vinaya, good. It's a buffer. In this solution, in one case, the concentration of HCN is 0.20 molar and the concentration of CN minus is 0.10 molar. In the second case, the concentration of HCN, this one, is 0.20 molar and CN minus is also 0.20 molar. Second solution. Third solution, this one is 0.30 molar and this one is 0.60 molar. Can you tell me which one is the best buffer? Best buffer solution, solution 1, 2 or 3? Identify best buffer without doing calculations. Without doing calculations. Yes, this one. This one is the best buffer. And if I use Henderson equation, then I'll get pH equals to, complete it. For the best buffer, pH equals to Henderson equation we are using. pKa, yes, Sanjana, very good. Vinaya, good. This is the condition for best buffer. Okay. Now here, what are you expecting? pH will be more than or less than pKa? pH. They are not equal. Is it going to be more or less? Just check who is more, the acid or the base. This is the base, right? Conjugate base. This is the acid. Who is more? The acid is more. So pH, for if acid is more, pH will decrease or pH will increase? If acid is more. Yeah, so mark it. Mark it like this. So this we are playing a trick without doing calculation because in the exam, you don't have time to calculate every time. You can use these simple tricks also. Check here. So this one, what is more? This is the acid and this is the base, conjugate base of the acid. So what is more? The base is more. If base is more, pH will increase or decrease, Sanjana? It will increase. So it means pH is greater than pKa. This is one of the very good example. You write it down nicely and it's important to practice. You can see questions on my website where they are asking the pH. So even without calculation, if you think smartly, you can answer it. Okay. Now I'm coming on the next topic, the acid base properties of salt. Now children, first I'm going to again give you some concepts which we have already done in the unit. Okay. Dhruv is asking a question. Let's go back. Did I write something wrong, Dhruv? Which one? The first one? Here? Because the acid is more. Acid is more. If acid is more, pH goes down. So pH will be less than pK. This is acid, right? And acid is more. Okay, now coming on the next topic. Eyes on the next topic. We are talking about salts. If I give you an acid, you clearly know, oh, it's an acid. If I give you a base, you can call it as a base. You can identify it as a base just by looking at it. But salts, you're expecting them neither acidic nor basic. But no, it's not like that. Salts can also be acidic or basic. Salts. They can be acidic and basic, and we are going to learn how to identify them. And they can be neutral also. So we'll learn how to identify whether given salt is acid or base or neutral. For that, you should be very good with your strong acids and weak acids, and strong bases and weak bases, which I have given you practice many times. Still, if you have any problem, you can discuss with me. It's very important in this unit 8 that you should be perfectly good with identification of strong acids, strong bases, weak bases, which I have given you all the rules, all the tricks, everything. Okay, so let's start. First thing which we are going to learn, how to make a salt. So remember, a salt is formed when you take an acid and react it with a base. This equation we are doing from our 8th, 9th standard. Acid, bases, they react to give salt plus water. But water is optional. You will get water only if you take a base of hydroxide, metal hydroxide. If there is OH in the base, then you get water. If you take ammonia, there is no OH here, you will not get water. So it depends what type of base you are using. So when you make an acid react with a base, you get a salt. For example, if I say I want to prepare NaNO3, it's a salt. It's not acid, it's not a base, it's a salt. I want to prepare it. So can you tell me what acid and base I should use to get this salt? What acid and base? You know that metals are coming from bases. So this part should come from a base. And this part should come from an acid. So cations coming from the base, anions coming from the acid. Salts have cations and anions. Cation from the base. So what is the base of Na plus? Anyone? Na plus. Metals as a base are hydroxides. This is the base, right? Sodium hydroxide. And what is the acid of nitrate? Whatever charge is here, put that much number of hydrogen. Yes, yes, you know them. You know these two. Okay, this NaOH is a strong base or weak base? Now you're going to identify your strong bases and weak bases. What is the other product here, children? One more product because you are dealing with OH. So one more product, H2O. Is the equation balanced? Yes. You can see that water is also there. So when I mix NaOH with HNO3, I'll get this salt and water. Yes, now all the hands in the chat and answer. Is this a strong base or weak base? Check the list of your strong bases. It's a strong base. So what do you think for Na plus? What kind of conjugate acid is this? Na plus. What kind of conjugate? Is weak. What do you think for OH minus? What kind of conjugate of this? Water. What is it? Is weak, right? So we will focus on Na plus is weak. If it is weak, then call it as spectator. Spectator means just forget about it. It's not doing anything. HNO3. What kind of acid is this? Remember I gave you four, I think only four oxo acids which are strong. Sulfuric acid, nitric acid, perchloric acid and chloric acid, only four, and I'm asking you to memorize it. Nitric acid is one of them, a strong acid. Only four acids I'm asking from the starting only, from the starting of this unit. In fact, I told you all these things in unit 4 also, because in unit 4 we did some acid-base reactions. Titrations we left because titration I'm going to cover in this unit. So what kind of acid is this? Strong. Can you give me the conjugate base? Conjugate base, children, of this nitric acid. Remove H plus. So what do you think nitrate? Is nitrate is strong or weak? Is nitrate is strong or weak? It's weak conjugate base, yes. Consider it as spectator. Now let's come into the solution after the reaction in the solution. This is the solution. In the solution, you have Na plus, you have NO3 minus, you have water. Who is stronger here? Na plus? No. NO3 minus? No. So who is stronger? Now only one thing is left, water. This is stronger. It's a stronger acid. It's a stronger base than Na plus and nitrate. These are weaker than water. They are conjugates of strong base and strong acid. They are weaker than water. And whoever is stronger is going to control the pH. Whoever is stronger is going to control the pH. So, who is controlling the pH? You know, controlling means it is the one who is going to decide the pH of the solution. Controlling the pH because it is the only stronger here. And what's the pH of water? We did that autoionization of water. What's the pH? 7. So what kind of salt is NaNO3? What kind of salt? Neutral. Neutral. So what's the condition needed for a neutral salt? Condition. Yes, Ashita, what's the condition? A salt of strong acid with strong base, that salt will be neutral. If you take a strong acid and strong base and you're getting a salt, that salt will be neutral. pH will be 7. Sometimes they ask this question, why is it neutral? Why the pH is 7? Then you have to answer that here water is going to control the pH because water is the only one who is stronger. Other things are weak. So water is controlling the pH. So water is pH 7. That's why this salt is pH 7, which is neutral. Anyone having any problem in understanding this neutral salt? Because this is the first example and it's very simple. Water is controlling the pH. Now we have to see slightly complicated examples of the salts. Ready? Okay, I'm going to clear it. I want to talk about this salt, NaCN. This one. It has Na plus and Cn minus. Now in this salt, the Na plus has come from a base, the cations from the base. The anion has come from an acid. Can you identify acid and base here? What base? Yes, please answer. Ashita, answer it. What base? Yes, Vinaya, very good. And what acid? Acid? What acid? Complete the equation. Okay. Now this acid is weak or strong? This base is strong. We already know. We have discussed this. This is a weak acid or strong acid? It's weak acid. Now the conjugate of this strong base, Na plus spectator, is weak, not going to do anything in the water, very weak. But this Cn minus, the conjugate base, is a strong conjugate base. Strong means, is it stronger like NaOH? No, no, no. It's stronger than water. It's stronger than water. Remember that. Some children they say that, oh, strong conjugate base means like NaOH, KOH. No, they are still very weak, very, very weak. Only thing is that they are stronger than water. That's why we say that, okay, they are strong. They are stronger than water. So now let's see the final picture of the solution. This is solution finally. This is final. What all is there? Na plus. What else? Cn minus. What else? Water. Can you tell me who is going to control the pH? Who is stronger? Yes, they can ask. Then you can say that Cn minus is a conjugate of a weak acid. Like you know that HCN has a Ka value, if I'm not wrong, somewhere around 10 raised to power minus 9 something. Then Cn minus, get the Kb value. Kb value is Kw over Ka. That is 1.0 times 10 raised to power minus 14 divided by 10 raised to power minus 9. How much is the answer? 10 raised to power minus 5. Isn't it greater than 10 raised to power minus 14? Yes or no? This is greater, right? That's why it is stronger. But is it strong? Is it strong base? No. 10 raised to power minus 5 is still less than 1. It's still weak, very weak. But only thing is stronger than water. So if they ask, you can answer like this. You calculate the Kb, but for that they will give you the Ka value. Then you calculate Kb value, compare it with Kw, and then you can easily discuss the strength. Okay, so who is stronger here, children? In the final solution? This is the final solution. Sarayu, who is stronger? Finally, who is going to control the pH? In the final solution, whoever is stronger is going to control the pH. Yes, please answer. Is Na plus stronger? No. Is Cn minus stronger? Yes. Is water? No. So who will control the pH? Cn minus. If Cn minus is going to control the pH, Cn minus is a base. It's going to react with water like a base. So please understand this equation. Very soon we are going to do titrations where I'll ask you to write these equations. Cn minus is the base and water is now acid. And complete the equation. Complete it. Base will take hydrogen from water and will give you OH minus. So what is the solution? Is basic. You are getting OH minus. What's the pH of the water of that solution? Greater than 7. So what type of salt is NaCN? Is a basic salt. Basic. So can I say that if I take a weak acid with a strong base, then the conjugate of this weak acid, which is strong conjugate base, is going to control the pH of the solution. So pH will be greater than 7 by this reaction, greater than 7. So it's a basic salt. Basic. We are good with this? So if your conjugate is a strong base, then it's basic. If your conjugate is a strong acid, then it's acidic. But we should know how to write down these equations also. This is called as hydrolysis of the salt. Don't worry if you don't know the name. Hydrolysis means reaction with water. Hydrolysis, reaction with water. And you are taking the Cn minus of a salt. Hydrolysis of a salt. NaCN, hydrolyzing. Is getting hydrolyzed in water, giving you OH minus, making the pH greater than 7. Any questions? What about rest of you? Okay. So don't worry, we are just starting, then we are going to practice questions. So please, if you have any questions, start asking because we have to practice a lot of question on this. I'm giving you another salt. Can you tell me what kind of base and acid can give you this salt? This is ammonium chloride. So it means this should come from a base. and this should come from an acid. So what base can give you ammonium? Yes, Isabella? What base can give you ammonium? Mhm. Yes, yes, very good. Ammonia. And ammonia is a weak base or strong base? It's a weak base. And what acid can give you the Cl minus? HCl. And HCl is a strong acid, right? Now write down their conjugates. What's the conjugate of this weak base? Means add H plus is ammonium. Is this ammonium a strong conjugate acid? Yes, strong, because it has come from a weak base. What about HCl? Is going to give you Cl minus. Is this HCl going to give you, is it a strong? No, it's a weak conjugate base. So the weak conjugate base means weaker than water. Spectator, not going to do anything with the pH, not going to control anything. So who is going to now, what all is there in the solution? If I take ammonium chloride, what all there in the solution? Ammonium, Cl minus, and water. Now out of these three, which one is stronger? Which one is stronger? Ammonium, chloride, or water? Yes. So this is the one who is going to control the pH. It will control the pH. But what is it? Is it an acid or a base? Ammonium. What is ammonium? Acid or base? It's an acid. So pH of this solution will be less than 7 or more than 7? pH will be less than 7 or more than 7? Lasya, you are there? Less than 7. So what type of salt? Ammonium chloride. What type of salt? Acidic. Because it has a strong conjugate acid of a weak base. Can you prove it that it's an acidic salt? Yes, because ammonium is stronger acid, it's a strong conjugate acid than water. So when you put ammonium in water, it's going to work like an acid and it will force water to behave like a base. Can you complete the equation now? Proton, donor, acceptor. What's the product? Give the product, children. Water is the base. It's taking H plus. Ammonium is giving H plus. What's the conjugate base of this ammonium? Remove H plus. Remove H plus. Is ammonia, yes. It's an acid. Acid means proton donor. The Bronsted-Lowry acid base definition. And the base is taking H plus. Add H plus. Add H plus. Bronsted-Lowry definition. So what are you getting in water? You're getting hydronium. See? Hydroniums are formed. So these hydroniums will make the pH less than 7. It's acidic solution, acidic. If you're getting hydronium, acidic solution. If you're getting OH minus, basic solution. It's like that. Is it okay? So this is acidic. Now, are you ready for questions, children? So to answer the question, I'm giving you the steps. First step, identify acid and base which is giving you that salt. Identify acid or base. Okay, then second step, check. Check the strong conjugates. Strong conjugates. Third, if it has a strong conjugate base, then pH will be more than 7. Then it's a basic solution. If it has a strong conjugate acid, then pH is less than 7. But fourth step, see, strong conjugate base, pH is more than 7, and you can call it as basic salt. Basic salt. pH is less than 7, you can call it as acidic salt. But if you are getting a weak conjugate acid, a weak conjugate base, if both of them are weak, then neutral. Then who is stronger there? Water. Water will be stronger. So we are going to do few questions on it, and after that we can end the class, but let's do some questions. We still have time, so please don't leave the class. We are doing questions for the identification of acid and bases. Please write on this box. In the review classes, I'm planning to give you these kind of hints so that you can do your questions very fast. Concepts we are doing right now. So we'll work on plenty of questions, and every time I'll give you the sequence of thinking, how to think in the exam. But come prepared with your concepts. So I'll declare that this is the topic we are going to do. So you watch the old videos, read the book, do some quizzes on the website or wherever you're doing, because you people are not doing quizzes. That's not good. And then come in the review class, and then you will understand all these tricks and sequences which I'm going to discuss. So let's see whether we can use this sequence. Ready for first question? Here, this one. Which one is most acidic here? Check the list. Which one is most acidic in this list? HCl. Yes. Which one is most basic in the list? Vinaya in the list. Most basic. KOH. Yes. It's the base, strong acid. We know it. That is the reason I'm asking you to practice strong acids and strong bases. Now let's work with this KNO3. It's a salt, right? So can you identify the acid and base in this KNO3? What acid? What base? Cations, anions. Cation will go for the base, anion will go for the acid. So can you identify? If it is metal, then it should be a hydroxide. Yes, KOH. Oh, are you writing KOH for this one? K plus I can get from KOH. K plus, right? So let's write on the equation in the right way. I want to prepare KNO3. So I can get K from KOH. And Vinaya is right. What about rest of you? Not answering? Are you listening, children? It's important. Shrihan, Lasya, Sarayu. Sarayu are not answering. Saranya, Siri. Siri, you are also not answering much today. You're understanding everything? Siri. Okay. This is water. So what is the conjugate of this? K plus. Is it strong or weak? So identify your base. K plus is strong or weak, Sanjana? KOH is strong base, right? So K plus is weak conjugate acid, right? Okay, HNO3. Is it strong or weak, Isabella? HNO3? Is it a strong acid or weak acid? It is strong acid. So its conjugate is, write on the conjugate. Remove H plus, remove this hydrogen. Is weak. So this is weak. Weak conjugate base. Both of them are weak. Who is going to control the pH? If I put KNO3 in water, who will control the pH? Water. So what's the pH of this solution? pH will be 7. And why is it 7? Because this is a neutral salt. Is neutral salt has K plus and nitrate. Both of them are very weak. So pH is 7. Neutral salt. So can I put this KNO3 in the center? Because it's neutral. It's neither acidic nor basic. So I'm placing it in the center. Now let's work with the next one. KCN. We are going to use the same concept. KCN. Identify acid and base which can give you this KCN. Yes, who can give you KCN? KOH and yes, Dhruv, HCN. Now, and water is also one of the product. Now this KOH, strong or weak base? What is it? KOH. Is it a strong base or weak base? Strong base. So K plus, strong or weak? This K plus, this one is weak conjugate acid. Spectator, not doing anything. HCN, strong or weak? Is weak acid. So Cn minus, this Cn minus, strong or weak? Is strong conjugate base. So who will control the pH? K plus, Cn minus or water? Who will control the pH? The base. If base is controlling the pH will be more than 7 or less than 7? Is more than 7. So KCN is a basic salt or acidic salt? Basic. So where should I write KCN? Here or here? Where should I write? KCN. It's a basic salt. KNO3 is neutral. Very good, Dhruv. Very good. Very fast answers. Very good. KCN. Yeah. Yes, Isabella. Perfect. Now let's work with this ammonium chloride. Ammonium chloride. Ready? Find the acid and base. This is ammonium, this is chloride. And remember, cations are coming from the base. These lines I'm giving you so that you should not be very confused in the exam. So keep repeating it. Anions are coming from the acid. Now identify who can give you ammonium, which base. You know it very well. It's ammonia. And who can give you the Cl minus? Who can give you Cl minus? HCl. I just want to tell you one thing, children, before we finish this question. Very important thing that please try to learn in the class. Don't think that videos are there and I'll watch the video later on. Just ask yourself, if I cannot pay attention in the class, in the live class, how I'm going to hold myself in the recorded video where no one is asking a question from you. I'm asking plenty of them there also, but I'm not forcing you to answer there. So recorded classes are just a precaution. Take them as a precaution that I didn't attend the class, so I'll watch it. Don't take it as something, okay, I'll just relax in the class and watch it later on. That later on will never come. Your exam will come, but later on will not come. So understand this. And it's my experience which is saying all these things. I've seen plenty of students, those who are active in the class and doing the quizzes. You take my guarantee, 5. If it is less than 5, then you can ask me that. You said this. But those who are not doing quizzes and not answering in the class, I cannot promise anything to them. Because it's not only teaching, it's your part is also important, learning and practicing. So your part is more important than my part. Okay, now ammonium. This ammonium is a strong conjugate acid or weak? It has come from weak base, right? This is weak base. This is strong acid. So what is ammonium? Ammonium is ammonium is strong conjugate acid. Shrihan. And Cl minus has come from the strong acid. So Cl minus is weak conjugate base. Ignore it. A spectator. Who is going to control the pH? Ammonium, Cl minus, or water? Who will control the pH? Who is stronger? Ammonium is stronger. So pH, this is acid, right? This is acid. So the pH will be, because it's an acid, so pH will be less than 7. So where should I place it here? Where should I place it? Here, ammonium chloride. Yes. It's definitely weaker than HCl, right? It's weaker than HCl, but it's acidic. pH will be somewhere around, I think, 5, 6. It depends on the concentration. Yes, Lasya. So we have arranged all of them. The strongest acid, the strongest base, the neutral salt, neutral, and then this is acidic and this is basic. So we have arranged all of them. Very important question. Now last question, this question. The pH is 8.02. So what kind of salt is this? Acidic, basic? 8.02. pH is more than 7. It's a basic salt. So if I give you NaOCl and NaCl, then NaOCl has Na plus, OCl minus. Na plus has come from NaOH, which is a strong base. So Na plus is spectator, just spectator. And OCl minus has come from hypochlorous acid, weak acid. So this is strong conjugate base. This one. You're getting it, children? This is base. So the salt is this. What about this? Na plus has come from NaOH. So Na plus is spectator because it's a strong base. Cl minus has come from HCl, which is a strong acid. So this is also spectator. So what kind of salt is this? Neutral. Neither acidic nor basic. So what's the answer? This one, right? I'll discuss this example, this question in the next class. And in the morning, Sunday morning, you have a class. Please join the class because we are going to finish these salts and we'll start with titrations. So see you tomorrow. Bye.